What's up, what's up, what's up? Get everything organized here. It might be a little too loud, just a little bit. Okay, it's Friday, and I'm bored because I got no friends. I got nothing to do. I have hobbies, but I don't know. I feel like I could stream. It's funny, like streaming. If you enjoy it, you could just do it all. You could just do it as a hobby, I guess. I mean, it's a job for a lot of people, but well, I think most people just do it for fun. I mean, you really shouldn't do anything unless you're enjoying it, right? Unless you're like forced to do it or something. But you know what I mean. So yeah, today isn't a atypical stream, I guess. Um, for one, it's Friday. I don't usually stream on Fridays. Usually I stream on my days off. Tomorrow I'm off. I may or may not stream, depends. I don't have any like backup ideas if we finish what we're doing today. But we could probably just goof off and play a game or something. So there's that. It's Friday. And the second weird thing is that I worked today, so usually I don't, like I said, I don't stream on my work days. But I got off at like 10 o'clock today. So I was able to get a nap in, get some food, you know, had a call with my dad, so I got that out of the way. Paid rent, even though it's not due until the 1st or whatever, but I paid it ahead of time. So everything's looking good. And now I figured I could just stream now rather than waiting until like, 11 or 12 tomorrow. I could just knock it out now because I try to stream twice a day. So I got nothing going on at the moment, so might as well do it now. Had a coupon. I went to Arby's. I had a coupon, and the Arby's burgers, which I think they've been doing like burgers for a couple of years now or something, but I'm always surprised how good the Arby's burger is, and I think it's because they make them to order. Um, I think I don't know, but or maybe it's the sauce they put on the burger or something. But it was pretty tasty, and the coupon that I had was it was like a free medium fry and medium drink with any sandwich purchase. So I was like, I'll just get a burger because I usually get the roast beef sandwich or something, or chicken sandwich or something like that. But any excuse to get the burger, I'll just go with the burger. So yeah. Okay. I guess we'll just jump into it. Um, is this updated? Yeah, I mean it's not completely the stream title, but it's good enough. No, I don't remember where we left off last stream. But it was close to this on the right here. It might have been a little bit different, but currently, this little shell guy right here is a sprite, and I can show you that real quick. Let's see, background. Oh, don't have color. Hold on. There we go. So a sprite is just a mesh. Well, they're usually a 2D mesh, or like a plane geometry. So in this case, like a square. It doesn't have to be a square necessarily, but um, it's always facing the camera. So as I like rotate around the scene, has the orbit controls. The square here is always facing the camera. And the sprite itself is created right here, added to that scene right here, main scene. And the shell thing here is a render target texture. So down here, we have a second scene in this promise callback. Second scene that this shell thing is a loaded model. That scene uses an environment map. It's kind of like a separate scene. And then we're changing the render target here and rendering to that target's texture, that secondary scene with this camera here. So this math right here is just about positioning the camera so that the shell is like right in the middle and it's got a good, you know, it's like fit to the camera, or I guess the camera is fit to it. Now looking at it, I think I might be able to bump that up just a little bit. Yeah, so we rendered to that render target. We only do that one time because we just need to get like one image at this moment. The idea today is that as this thing rotates around the scene, we need to get different shots of the object, of the shell. So maybe we have a shot where it's looking head on. So here's the shell, and maybe we get a shot like this, and a shot like this, and we go around this circle around the shell, and we get multiple shots of it, but they're all going to be flat textures, pretty much. Because, you know, when you render to something, you can only render to like a canvas or a render target or something that only has a width and a height. And it's all the colors in that canvas that are kind of creating the illusion of depth and stuff. But yeah, so we're going to get this camera, get different shots of the object around this circle. And then we're going to put all of those shots, those like views, they're like views of the same object with the camera positioned differently. We're going to place all of those into a render target texture, and then we're going to swap out that like parts of that texture depending on the rotation of the object here. So like if it's back here, well, it's hard to see it at the moment, but let's say that this is the, like, when it's added to the scene and the camera's not rotating, this is going to be, you know, its initial orientation for this one here. Let me turn off the auto rotate so I can explain it. So, and then as we go like around the object, we're going to move the camera this way to the left. We should be able to see the left side of the object, but it'll be a flat texture. So that's why we need to get shots of that left side of the object. And then if we were to come around the right side, we should see the right side of the object. And back here, where we do a whole 180, we should see the back of the object. And the whole reason to do this is that if you have like a really, really complicated, like back in the day, they used to do tricks like this, which in the link here kind of explains. Can you see that? Yeah, so this is a 2D texture, but it's used like a sprite atlas. And all you would do is, you know, you can index or sample from that texture however you want. So this is all just one big texture. You know, it's probably loaded into memory all at once, and then they're just selectively choosing which parts of that texture they're putting on to that sprite. we I don't think we have to worry about this nowadays unless you're rendering like many objects or many complex objects or something. Um, but you can also use this as like a level of detail kind of technique. So like if you had some object way in the distance, where you're not going to see like the finer details of the like textures on the object or lighting or anything like that, you could just swap it out with a sprite. And then as you get closer to that object, then you would presumably you'd already have like its 3D mesh loaded into memory, and then you just swap out that sprite with the 3D mesh at that like some distance or something like that. So it's just kind of like a performance technique. There's no sense in loading a very complex object and putting it in the scene and drawing it and all this if you aren't going to see most of it or some of the like details of the object or something like that. Also, if you're only ever going to see the front of it, um, you know, you're only ever going to control the camera in such a way where you'll only ever see like one angle of it, then you could put it on a sprite. Uh, Maybe in the one scene you use the object and you can get different shots of it or whatever, but maybe in another scene or something, you're only going to view that object from the front or from the back or whatever. So that's another use case for it. But for our case, it's just going to be a demonstration of like how to do that. Um, and yeah, I think we'll get started on it. Um, so let's turn back on the orbit controls, like the rotation. So now we have something to test it with. So how do I want to... This is going to be kind of a short stream. I think this will be pretty easy to knock out. But we'll see. And after we get it completed, it might be time for a little bit of cleanup in this file. So, I felt like there was like... Yeah, look at that. I think I had some crumbs on my shirt. Yeah, so what do we need to do? So, this texture, if we're gonna lay this out, it's like this. Depending on how many different shots of this object that we want, we're just gonna lay them out one by one in a texture like this. So, you know, if I had some object in the scene like this, and my camera was looking at it, oops, like this, you know, maybe we'd get a shot like that. That's going to be in the first slot. As we rotate the camera this way, and we get a second shot, maybe this side is colored white or something. You know, we'll have a shot of it like this, we'll have something like that. And if we get a shot of the back of it, maybe the back of it is like orange or something. That's what we'll put into that slot. And just for completion, just so we can see the whole picture, maybe this side is like green or something. So the back side is this color, and then this side here is green. So this is like the back face, not this top face, but the back face. Like that. And let's make this a little bit better. So yeah, we're gonna get all these 4 shots, put them into a render target texture, and then we just need to, depending on where the camera is, like the main scene camera, we're just going to grab hold of one of these like cells almost, or like you know, something from this atlas. Um, and that's easy enough to do because this is just indexed from zero. Well, the UV texture, like the UV coordinates of the texture, range from 0 to 1. So if you want to grab just this one, this is a count of 4, like we've got 4 different shots. So this is 0, 1, 2, and 3. To get to, let's say, this third one here, you know that your UVs go from 0 to 1. You would need to take, 1 divided by the count. Count in this case is 4. You got 4 objects in here. And then that's going to be the offset to get to each of these like section like starting points, right? So to get to the second one, we would take this number here, multiply it by 2, and that will get us here. But how do we know how big this thing is? Well, it's just going to be a quarter of, like, that's what's nice about this arranging from 0 to 1. We know that we're going to start at 2/4 or half, like halfway into this texture. And then the amount that we stride, like not stride, but the amount that we go is going to be just a quarter. So this is the start. And then this is the end, right? This is where we're going to end. So that's 2/4 or 1/2. And it's the same thing if you wanted to get, different parts of, like if you wanted to get this green one, well, that's at position 3, so you would take 3 times this, and so on. If you're at position 4, we kind of want this to wrap back around. So 4 in this case, like this is, 1, 2, and 3, and then 4 here is, linked up with 0. It's the same thing. We can just mod this whole thing by 4 or whatever. It's 4 mod 4, or I guess it would be mod, what is it? Is 4 mod 4 0? It might be 1, but we'll play around with it to get it correct. But in any case, we want like this here to wrap back around to the start. So if we ever get like a if we could ever get like a 1 out of here, we want that to actually be 0. Or if we ever get like a 4 out of here, we want that to be 0. And that's easy to do. I'll show you how to do that. So this texture here, where is it? Texture here. This texture in three.js, they have 2 properties that we're going to need. The first one is going to be the repeat. And I don't necessarily like the names that they give these things, but I can see why they're named in such a way. But you can think of the repeat as, how large or how wide are each of these cells. And like I said, that's 1 over the count. The count is 4 in this case, but in our case, it's going to be 16. Because what we're going to do is get, rotate around this thing and move the camera 16, like, imagine your unit circle here. Something like that. It starts out here. This is 2 pi to go a full rotation. So you just take 2 pi divided by the count will tell you how much you need to rotate your camera every time. So if the count is C, that'll be like your rotation amount. So, on the first go, and maybe like that, and so on. And then when count is, yeah, so that'll be the index. So this is at position 1 or 0, 1, 2, 3. So to tell you like what this rotation needs to be, you just multiply it by that index. And that will tell you from the like x-axis how much you need to rotate to get that next shot. And let's do that. Let's create those cameras, and there's this really cool thing called an array camera, and I'll show you that in a moment. But I finally found a use case for array camera, which is something that you usually use in three.js for I guess like WebXR or something, or augmented. I guess it's WebXR, or maybe it's like VR stuff or something, where you have two cameras, one for each eye or something like that, and it's faster to render. Depending on where you're going to output the view of each camera or something, and then combine them together or something like that. It's faster to use an array camera if you're going to have uh, multiple views of the same scene or something like that, and they're all viewed through different cameras. Um, so let's create some cameras. Let's say for I equal to 0, less than the count, I plus equals 1. We can just get this, put it here. So without any translation around that unit circle here, it's going to be on the z-axis. So in three.js, you have something like this. This is the origin here. This is 0, 0, 0. This is the positive z-axis. So the camera's been moved out here, and then our shell or whatever is loaded right here. Not very good at drawing these things, but that's our first shot. Now we need to rotate it around. So how do you do that? You can actually do this position dot apply axis angle, and it will take an axis and the angle that you want to rotate by. And we know we're going to rotate around this point, or this like axis here. So this is actually the y-axis, or the positive y-axis. So if we just get a unit vector in that direction, then we can rotate around that unit vector by the angle here. So let's say that that's y hat for unit vectors, I guess. That's what they use in physics. I'll just call it y hat. It's a new vector 3, and it's already been normalized, so its magnitude is 1 if you just have 1 right here. That's what's nice about these like IJK vectors or something, these y hats and z hats and all this. So we're going to rotate around that, and now we don't know the angle that we're going to rotate, but let's figure that out. So that's what this calculation here is. This will be, I don't know what a good name to call this is, but I'm just going to call it A. So A is, it's 2 pi around the whole circle. You have to do it this way. And then every like sector, this little chunk here, or I guess like this angle here, is going to be divided by the count. So we're just splitting up that like pi. We're kind of like chopping up or cutting the pi into 2 pi divided by count, and then that'll give us that many. Like if we multiply this by count, then we get back to 2 pi, right? So this is easy. It's just a times I. At 0, this will be 0, so no rotation. At 1, this will be, or I guess, let's see. Is it divided by count? Oh yeah, it is. So our count here is 16. But at 1, right, this will be a times 1, so whatever this number is, times 1. Imagine if this was like 4 or something, you'd move 2 divided by 4, like if this was 4, this would reduce. If count is 4, for example, this will be 2 times pi divided by 4, which, would turn out to be pi on 2 if you were to reduce it. So you'd go, up to here. And then if it was 2, this would be 2 of those. So you'd be here at a full pi and then so on. I think that makes sense. But we need to put this camera in a cameras array. So that'll be cameras. And then that's an empty array. It's actually going to be typed as this perspective array or perspective camera array. And then our actual camera is going to be a new array camera. And this accepts that cameras array. But if you want to use this thing, fill up the docs here. Yeah, talks about it here. It's mandatory to define a viewport for each of your cameras. And that viewport is going to tell it where to draw that view into the render target. So this is actually pretty easy because we don't have to deal with any like Y component of this. We're just going to render, like change their X's every time. So the first camera in this array corresponds to this thing here. Second one to this one here, and third is this one, and so on. So you would take your camera, and each camera actually has this viewport property on it for this specific use case, I believe. But it's a vector 4. And it's an X, Y, and a width and a height. So the X here, that's going to be, we have this render target, or RT size. When we make the render target here, this is its width. So we know that each of these like squares is going to be 128 units wide, and we've got count number of them. So we take that number, we multiply by count, and that's the width of the actual target, its texture. And then the height here, we want it to be a square. So each of these has RT size width and RT size height. So we would take this, take the I, and we're going to multiply it by, because this is the X position. So that, and then we know that this will be 0 because we're always going to start at the top. And we're not going to move down any. Like, it's going to be 0, which is the top of the texture. And then the width and the height here, we want that to be a perfect square. So that's our viewport. And if we take a look at the... We don't see anything. I don't know if we have any errors. Let me see. Okay, no errors. That's a good sign, I guess. Oh, I know. So this is where we need to tell it like where to grab hold of the texture, or like where to grab those UV coordinates. I don't know how it was so dark in this room at night. I have the ceiling light on, or like the fan light on, but it's not really that good. Might be able to open the windows a little bit. Yeah, that's a little bit better, I guess. Now we have this. If we take this off, okay, we don't see anything. Let me check my notes. Oh yeah, I remember now. So when you use this viewport thing, if you ever look at the examples, um, you set the viewport and then you have to update the projection matrix. And then as you rotate the camera around, as you rotate the camera around here, like here's our object, here's the camera. Rotating it around here it will preserve the like the local rotation of the camera. So we need to actually we need to turn it so that it's still facing the object. So we need to go from this to this. And that's easy enough to do because every 3D, like object 3D, which camera inherits from object 3D, or the perspective camera inherits from camera, which inherits from object 3D, has this look at method. And then you can either pass in a vector or you can pass in an XYZ. This shell is not like translated at all. It's always just going to be put into the center of the scene, so you can just do its position. But if you do this, you also need to call camera dot. You don't need to do this in all cases, but I'll tell you why in a second, why you need to call this update matrix. Yeah, updates the local transform. Let's save it and make sure this is working. Oh, we need to push that camera. That's one thing that I forgot to do. So after we, like, you know, clean it or get it ready, we just push it into that camera's array. And this is kind of right. Not what I expected, but it's close. This is what I expected. But if you take off this update matrix thing, and if you set the offset, let's do that real quick. So I'll explain this part next. When you take that texture, and it has an offset property, and if you set it to 1 over the count, let me think about this. Make sure this is right. One minus the or what is that? Yeah, there's a way to offset this manually. I have my repeat set. Yeah. Dang it. Let's see. Where is it? Let's do it up here. So normally it's 0, meaning like no offset, but we're going to set it to 1 over the count. Let me make sure this is done right. Oh yeah, we didn't actually rotate it. Yeah, we did, right here. If we put that here, where do we get? Same result? That's correct. Hmm. Okay, let's see. Let's do 2? If we don't do this, it's hard to tell. But I think our camera shots are off. Yeah, let's drop this down to 4 so we can see it a little bit more clearly. Yeah, and I'd expect to see all 4 of them in here, but we don't see, I only see that first one. So something's broken with the array camera. Oh, I see it. This needs to be world. So world is the like world matrix, and then update matrix is like the local matrix. But you can kind of see already that we've got the front shot. I guess this is the back of the shell. And then the shell isn't symmetric, so the left and the right side are going to be different. So that's looking good. If you turn this back on, and then you set the offset right here. So initially it's 0, but if we take 1 over the count, or 2 over the count, oh, I have it on repeat, let's call it offset. So this is the first like cell in this thing. This thing here. What's the word for these in like sprite work or something? There's a name for, I guess these are individual sprites. And then you have your like texture atlas or your sprite atlas or something, which is a map of all the sprites, right? So that's the first one. This is the second one, third one, and we only have 4 of these, so that's the 4th one. So let's leave it at 4 for now. But what we need to do is calculate this anytime that the camera rotates. We need to recalculate the offset because it might have been changed. Because if we're back here, like here's the normal way that we view the object. If we're right here, that's fine. But if we're rotated like this, we need to see the this side of it, right? And then we need to see the back side of it like this. So we need to calculate this whenever the camera updates, or the main camera in this case, this one here. And that's something that you can do in a callback. So this orbit, where's orbit? Orbit down here has this change event. And that's anytime that the orbit controls updates the camera. So we can just log out the camera's position. Oh, it's main camera. You can see it's updating anytime that we rotate. If we turn off the auto rotate, it's not updating anymore. We're gonna need this position, and the way that you do this, or the way that I did this, I think there might be multiple ways to do this, is that you this math.atan2, so let's take a look at it. So math.atan2 will tell you in radians the this is, you know, normally done in 2 dimensions, but you can do it in 3 well, it only takes 2 arguments. We're gonna do it in 3 dimensions because we're gonna stay on that like flat plane. But if you needed to do it in 3 dimensions, that might be a good stream, is how do you calculate this angle in 3 dimensions or whatever, but we'll worry about that later. But it will tell you how much of an angle it, like let's say you had some object, oops, and this is in 2D space, you had some object that was maybe like all the way over here. And that object has an x and a y. And math.atan2, let's just say atan2, you pass in the y and you pass in the x, and it will tell you this angle here. So this has, you know, some vector out here. It will tell you the rotation of that vector around the x-axis. You know, this is your positive x-axis right here. So we can calculate the amount of rotation that the camera has. We want to calculate it around the z-axis though. So the way that three.js is set up is that your x and y are like this, and then your z comes like up. So your y comes up. So z is into and out of the screen. So there are other orientations, like in, or like, what do you call them, 3D coordinate systems and stuff. Like if you ever work in CAD, they like to do X, Y on the like surface, and then you go up in Z. And that's because, you know, usually you're drafting on like a flat surface, and then you're just elevating that. You know, most buildings are just extruded, you know, shapes or something in the Z direction. So you draw your shape on the paper. Maybe your building looks like this. I was gonna try to draw a star. You know, something like this. And then you just extrude that up off the paper. And usually when you're drawing this, you're so used to drawing this as the y-axis and this as the x-axis. But in three.js, they took the different approach that your screen, you know, you think about HTML canvases, something like this, and then into and out of the screen or out of the web page or whatever is the z-axis. So all that is to say is that we have something like this, where normally, let me get some color. You know, normally the atan2 takes the y and the x, Our y in this case is this axis. Or, yeah, this axis. Which is actually the z-axis. And the x is the same. So what we need to do is pass in the camera's z position and the camera's x position into this, and that will tell us the rotation in the zx plane around the x-axis. And what we can do with that is this number here ranges from, like, what we get out of that function call ranges from minus pi to pi. We can normalize this to go from 0 to 2 pi. And then what you can do with that is, you know, scale it to 0 to 1 range and then scale it up to what you need it to be, which is an index into that texture, or like an offset into that texture. Let's see. So we'll say that the angle is math.a10 2 main camera.z main camera.x. Now this is going to tell you around the x-axis. To get it to go to the z-axis, the rotation around the z-axis, all you have to do is subtract half of pi. And why is that? So remember that this is like this. I'm gonna draw the x and y plane. So something like this. This is z, and this is x. You have your unit circle here. This is hard to draw. I need to get a tablet or something. To get here, this is just a half turn, you know, not in your typical, like, positive direction, but in your negative direction. So each of these has, you know, pi over 2 radians. And to get from here to here, you just subtract pi over 2. And that will get you where you need to be. But if you do that, then your ranges will be different here. Let's do that real quick. Right here, we'll subtract half of pi. And then to get this to be, like, always positive, so now we get out a number that's between negative pi, so normally it would be minus pi to pi. But if we subtract that math.pi, this will be minus 2 pi to 0, I suppose. We can just add, like, if this is negative here, we add 2 pi, and that will, like, rotate it all the way, because every 2 pi rotations, you know, there's no difference between no rotation and 2 pi rotations, and 4 pi rotations, and so on. But we want this to be a positive number. So all we need to do, we can even add like 4 pi rotations or something. We just need both of these endpoints to be positive. And if you do it this way, this knocks out 2 birds with 1 stone, and because you want 0 on the left, because we're going to scale up this range, or scale it to be, you know, something that we need. But usually when you scale things, you want to leave the left side at 0, and the right side is what gets scaled up. And it's a linear scaling, so everything in between is scaled proportionately. But the way that you do scalings is by multiplying. And if you have something that's 0 multiplied by something else, you always get 0 out. So 0 maps to 0 is what you want. And adding 2 pi over here, that'll get you that 0 that you need. And adding 2 pi over here will get you up to 2 pi. And the reason why we're adding 2 pi is because this minus 2 pi and positive 2 pi around the unit circle is going to be the same rotation. Like, you're going to end up at the same position. It's not the same rotation necessarily, but it will get you to the same position. And not only that, but this term here will go to 0. But what you want now is this to go from 0 to 1. And so that's really easy to do. Let's take it over here. This is our range now. We just divide it out by 2 pi. And that'll leave 0 untouched, and then 1. 2 pi over 2 pi will give you 1 on this side. So we say if the angle that we get out is less than 0, we're going to add 2 pi to it. That way we get back to, positive value. And this now needs to be a let. Alright. So now we're at the range 0 to 1. Now, we need this to be an index or an offset into... I'm going to draw it again here. Not very good drawing, but that's okay. So we already got this from 0 to 1. All you need to do is divide this by the count, or the length of this. So you would take that, you would divide by the count, and then this needs to be an integer value. Or sorry, let's see. This needs to be... Let me think about this. I think you need to multiply by the count, because then you'll go from 0 to the count. Yeah, 0 to the count. So this is 4 items in here, so this has a length of 4. Multiplying this by 4 will get you from 0 to 4. But this has decimal numbers in between. What we want is integer values. Because what we're going to do with this number is multiply it by 1 over the count. And that will be our texture offset. So that's super easy to do. You just take the floor of it. And we know that we're working in a range here that's going to give us more than like 2 values. You know, if you had still 0 to 1, you take the floor of this, you're only going to get 2 values. This would be like, I only ever have 1 object in the array. But if I have 4 objects in the array, now I can get 0, 1, 2, and 3. And 4 if, floor of 4 is still 4. But I have a trick for that too. So that's the wraparound case. This is the floor syntax. So you would take the angle and you would just floor it. Now you'll get a number that is a whole number, and it will go from 0 to the count. If it is the count, we want to have it wrap around, so you would just mod by the count. I guess. Yeah. Yeah, I think there's two ways to do this, but I'll do the way that I have in my notes. Um, so here, the offset, so at the end of the day, we're going to take the texture and we're going to set its offset equals some number. This is just the X. We don't need to offset the Y any because we only have a single row of these like camera shots, which I want a better name for what it is, but I'm gonna roll with camera shots or continue with that term. To calculate this X value, we know that the offset ranges from 0 to 1. Is this I guess this is like the UV of the texture. And what it does is it probably has your texture, and your UVs go from 0 to 1 like this. You know, you'd offset by some amount, and then your repeat will tell you how much each of these gets repeated for. Maybe R is like, R needs to be less than 1, but it should probably also be, well, depending on how you wrap your textures. And there's ways to set your wrappings and stuff. That's kind of outside of the scope of this, but we've already told it what the repeat was at the top here. You know that each of these cells or whatever are going to be length of 1 over the count. But now we're telling it where to offset into the texture before we do that indexing or that sampling. So it is going to be the angle. What is it? This angle is from 0 to 16. So angle over count. Let's see what that does. What's the problem here? Oh, this is position and position. So we're getting somewhere, but this isn't quite right. Because over here we have numbers that are outside of the range. Or it might actually be, like if we log it. So that's in our range, but these numbers out here are not in the range. So we need to fix that. I wonder if I could just fix it here. Because this might be a better solution. Do I need to wrap this? Just looking at things here. Oh, I forgot to divide by 2 pi here. Yeah, so we see it goes back there. This is almost right. You can tell that it's nearly there. So once we hit that like quarter turn, it's showing the wrong side. But you can show the correct side by just doing 1 minus this, I believe. But here, where it's equal to 0... Oh, that's not right. We take 1 minus this number. Let's take a look at x. So here x is 1. And what we need to do is we need to wrap 1 back to 0. Here it's 0.75. That's correct because we're rotating to the left of the object, I guess. Oh, maybe this is off. No, this is right. Yeah, let's do that first and then we'll debug it if needed. Yeah, so maybe this will be easier to see with more images or more shots. Shots. We bump this to 16. Let's just let it run. Yeah, you can tell like we're kind of, it looks like we're wrapping around that shell there. And it'll look even better if I take off the camera or the scene background. And then if I increase the I don't think you have to mod by the count there. Yeah, I think you can just do this. Because the modding or whatever will happen here. So you'll be good. The only time this is ever equal to 1 is if this turns out to be 0. And you'll get 1 minus 0, and then 1 mod 1 is 0. I don't know if I like it though. Seems like you should be able to only do one mod. Okay, what's the x value here? And then let's do this so that's easier to read. So in the beginning here, it's 0 and 1. The offset is 1. And the only way this is 1, this here is 1 if this is 0, which is the angle is 0. So yeah, you do need that mod 1. And the other thing you could do is, you know, do things with the actual mesh, like scale it so that it's, you know, mirrored, not mirrored, but like it's positive and negative x or something are kind of like flipped. There's ways to do that. I'm gonna leave it like this. Yeah, I think I'll think about how I can get better lighting in here. I probably need a desk lamp or something. And I probably need to stop saying or something all the time. So you can tell there is an optimization to be had here. that we're running this every time the camera rotates, and it rotates, you know, by some amount every frame, right? Because in our render loop here, we're calling orbit.update, and that's what's, you know, updating the camera properties, like its position. But you can tell, like, this doesn't need to be recalculated, and I'll just make this pretty obvious. If we just have 2 shots, you can tell that all this here, it's not needing to be recalculated, that A or that angle value. Doing this part of it here doesn't need to happen. Because the value hasn't changed. If we log out what A is here, or sorry, angle here, you can see that it's 0 all the way until, you know, it needs to, because we only have two like views of this object. So what you can do to make this a little tiny bit faster, you still have to do this part of it, and there might be ways to even optimize this part of it, but I haven't thought about it too much. Because presumably this part here is the part that will probably take the most amount of time. I don't know. It's kind of like a micro optimization. You would just save that last A in a variable. Down here you'd say if last A is not A, or angle, probably should call this angle. Then we'll do this part of it. And the last angle is now that angle. So let's turn this back up. I haven't tested it with these kinds of numbers. But I would think it would work for odd numbers. For numbers that are not powers of 2. So that's kind of it. That's how you would achieve that. You can tell that it's only in the XZ plane because we don't have any like different. If we do this and we stay inside of this like plane here, you know, we've rotated the camera. How do I draw this? So this is the origin here. This is where the object is. And maybe the camera is out here somewhere. Oops. And then we have some kind of plane or something that this camera is going like this. And the view of that object, we don't have any like, all our Y's are the same. We didn't, in this camera loop here, we only rotated it around right here where we did the apply axis. Like we only rotated it in the ZX plane. So we don't have any shots of it like looking down on it or looking up to it. But you can do that. It's just that your texture would get really big. And the texture size is already kind of big. So let's take a look at it. Its width is RT. Well, let's do this so that it's more apparent. Target.texture.width. So it's already 2,000 or like 2 kilobytes wide, and it's not very tall, but is this kilobytes or something? I don't know, but Let me make sure that's right. Yeah. I mean, it's even bigger than that because each of these colors, yeah, each of these pixels has an RGBA color, so it's even larger than that. So this is close to the size of this texture in bytes. But I mean, I think it's a little bit easier to think about textures in terms of like images. This thing is, 2000 pixels wide and 128 pixels tall. So it's a pretty big texture to begin with. If you were to put it on the screen here, which we can do, um, but I kind of want to save that for maybe a second or like a third part of this kind of adventure. um, how do you extract that? Because this texture, after this loop here, once you render it to it right here, um, this render target texture, you can, if you want to view it or like put it into an HTML image element, there's a way to do that, but it's kind of a little tricky. Um, but there's some image, for example, that this texture is using as a source, and we've written to it, and that image is this dimensions. So I don't know if like I don't know if you're familiar with like image sizes. I think there might be APIs for this. Hey, what is this? What's a good image? Whatever I've been into. I've been into Inuyasha. Been watching a lot of that. But if we just take a look at this image, for example, this is 600, or this is 500 by 352. So it's 4 times as wide as this image, and about half the, well, I don't know, maybe like down to here. But this is all to say that this is a pretty big texture. And if you were to get shots of, oh, I lost my window. If you wanted like vertical shots of the scene, let's do this. Your texture would be even larger. Which, if that's the only texture you have in the scene, that's probably fine. But, if you were loading, and you're not loading this, but you might, if you were to do this as kind of like a build step, when you build your project and you make all these images and these textures and stuff, uh, you don't want to load a really big image over the wire. For example, like if we were to have 16 vertical shots around like, a circle like this, that's only in one plane as well. It'd be 16 of these, let's say. And then you'd need, so this would kind of be like a cube of shots in a way. You would need, you'd have a circle for every count. So if you had like 8 around your like XZ plane, and you had a circle for every angle of rotation, that would be like, we had 8 of these, and they're 64, let's say they're 64 by 64. and we had 8 of these. It's gonna be a big number. It's gonna be a lot of images. It's gonna be a lot of camera shots. Um, and that's at 128. So if you were just to show you this too, as you like increase or decrease the RT size, you get better resolution and stuff. Um, can I even do like, is this gonna run out of memory? Probably ran out of memory. Yeah, the maximum width. I guess this is the maximum width and height. And our width is much more than that. So our width here. Oh, that is the width. So we're right at the like edge of how large we're allowed to be. Yeah. I didn't know that about textures. You're only allowed, I mean, I think you can do data textures. That might be worth looking into. But as you get larger like that, you're now into the territory of like, um, this should just be like a data buffer. I mean, textures are kind of like just data, they're just color data. But I think you'd want to use a different kind of, maybe that's what this is. I need to look into this. So I bet that you're allowed to have more data in this one. Oh, maybe this is not for this use case. Maybe it's for actually creating texture of like data that's not necessarily um, like an image. So if you had some readings or something, let's say this is an example, uh, but you wanted to sample something, but you didn't want to sample it like an image. You wanted to sample it like just a data set. Maybe that's what this is for. I think data 3D texture creates a three-dimensional texture from raw data. We kind of just want like 3D texture. I don't think they've got one. Pressed texture? I mean, there's ways to swap out that texture too. Or you can have more than one texture. I mean, I don't know. That might be cool to actually see if we could do this. But I don't think it would be, I don't know. I was kind of just going off of this here. Just trying to recreate this. So I don't have a boo model, I have a shell model or whatever, but this is kind of the same idea that so we achieved what we wanted to, but it would be cool to get some kind of vertical shots of the model or the mesh or something. You can see what music is playing on this. What time is it? Oh my gosh, it's almost 9 o'clock. This is usually when I go to bed. um, yeah, so I have two ideas from here. We already kind of talked about um, getting vertical shots of this thing. And in there, where you would kind of have like a sphere of shots, right? It would be like a discrete sphere, kind of like, vertexes on a sphere. Um, imagine if you had a sphere geometry and it had a low amount of these, like 8 or something. Every I can't stop it from rotating, but every like point here would be your camera getting a shot of the object that's in the middle of the sphere. Um, yeah. So there's that idea, but we'd have really large textures to figure out. Um, and it's like, at what point do you just render the model itself? You would just, I don't know. I think it would be better just to have a low poly version of your model, if you had something like that. So, like, this workflow here would benefit from systems that can quickly load in a texture and quickly sample from that texture and stuff. Um, or maybe even like quickly create a texture on the fly or something, right? So that's idea one. The second idea is how do you extract uh, this part of it? Oh man, sorry. No, this. So you've got, you've rendered to your render target with your camera array. Now, how do you get this part of it out so that you can like put it in the DOM? I kind of want to show this too while I think of it. This is what's happening here to our render target, except that we just have a single row of cameras. We don't have any Y offsets. And that I'll put in the chat for anybody that might be here. So that's what the camera array is doing. This array camera here. And it's using the camera's viewport to do this, which we set here. But getting that texture as an image, there's two ways I can think of to do it. Is, just reusing all of these like objects and stuff that we already have. For example, like we can like set the background here to be that render target texture. And let's see what that does. Oh. Oh, I need this to be main scene. Yeah. Because in the render loop, we're rendering the main scene. Right here. So yeah, like you would reuse, things that you already declared and stuff before you resize the canvas and all that to what the actual application is going to need. Because you only have to do this part of it once. You'd render to the scene that texture by setting it the scene's background. So all you need to do is just render it once to the canvas, and then this canvas has this what is it? To data URL, I think. Yeah. Once you've rendered to the canvas, you can just, now that it has like all its like pixels set and all that, then you can just create an image out of it like this. I don't know if this will work the first time around. But I'll try it. So this is a URL, like string. We can create a blob, I think that's what it's called. Or maybe not, but... And then now we need to load that image. So I actually have a helper for this for some other part of the project that's using it. Do I need to do that? I think I can just do this maybe? Let's see what happens. I might need to turn it into an object. Or like a blob or whatever it's called. Get the image out here. We'll do image dot. Or we'll do... This is not how you would do it in Svelte, but just for demonstration, I'll do it this way. Pen child image. And I think what's happening here is this part of it, where we set the repeat and stuff. I don't know, I'd have to play around with it, but I'd expect, you know, something like this to be an image down here, but it's not getting the correct, like it is down here, but it's not rendering correctly. So yeah, but you get the idea. Like you could reuse the camera and you can reuse the scene and blah blah blah. And if that was like, if you had a system like that, then you could, and this is where I might make a stream out of it, is how can you use three.js without a canvas? That would be a good use case for it. Or like you always have to have a canvas for your renderer, but you can make an off-screen canvas, so you could run this in like Node or something, where you would set up like a 3D scene that you're not going to be like viewing it in a window or a web page or something. You just want to create images out of it. But I'm pretty sure that would work. It would work in theory, but I don't know if like three.js references like window or things like that, and you'd have to stub those out and stuff. But I mean, I'll look into it. That would be interesting if we made something like that, or I made something like that. You know, doing 3D renders just to get images, kind of like what, however, you know, if that's what you want to do. Let's say you're writing like a textbook or something, and you need images to go with your, with the, you know, concepts that you're explaining. Is this still working? Oh, I need to set the repeat and I have to turn that off. And this I need to set back to this number here. Okay. So tomorrow I might do another short stream. Depends on what I feel like doing. Or we'll see. I'll probably get bored and stream again, but it'll be another short stream probably. That's kind of all I wanted to do tonight. Let me clean up some of this. But let me go over again what we did, and then I'll end the stream. And we might do a raid this time. Let's see who's online. If anybody. Yeah, I don't think so. Everybody has lives. Everybody's out there doing things with their friends and hanging out probably. That's cool. Yeah, so in this little demo, it is rendering a scene to a render target right here. And it's rendering the shell GLTF model here, adding it to a scene. It's positioning this many cameras around the object or the shell, and is rendering every camera's view into that texture. And once that's done, well, it doesn't happen afterwards, it happens asynchronously, but that texture is being used as a map in a sprite right here. And every time we rotate the camera around, we are modifying properties of the texture in such a way that it will show the corresponding segment or section of the texture that corresponds to the rotation of that model. And the math is involved here for determining what the angle is and what the offset into that texture is supposed to be. And it's pretty simple, actually. It's not too much code. I'm just thinking now, if I did do that, reusing, like you could just render right into the canvas. Like there's no point in rendering the targets into their target texture. Maybe that was the problem. Because what you would do is just render into the canvas directly. You know, you'd size it to be the width and height of the texture that you needed. Render to the scene, or render the scene because you set the background of the scene. And then after that, then you would set the like the main scene. You would render the main scene from then on. So you wouldn't even need a render target. You'd just be reusing. You know, you've already got a render target in the form of the scene, or in the form of the canvas. Yeah. Okay, I think there may or may not be a stream tomorrow, but if there is one, it'll probably be a shorter one. I think might take a trip over to Target to get a lamp or something if I'm going to be doing evening streams. I could definitely need better lighting, but this kind of looks like I'm a little bit evil or something. But I mean, you can kind of tell, like, the light is just right up here. It's just not a very good light. Well, it is a good light in person, but not for streaming. Okay, this will be uploaded to YouTube. I gotta start remembering to say this. So after the stream, I'll usually upload the VODs to YouTube. I need a command for this too, so I can shout out to YouTube. But I'll make that as well. So if anybody Well, I mean, the VOD is on Twitch, but only for a week. But if somebody wants to come back to this stream or something, a year from now, they're going to be on YouTube until the foreseeable future. And that's like after, stream ends and then it processes the VOD and makes sure that there's nothing in the VOD that I can't upload to YouTube. Um, so be on the lookout for that if you are interested. Other than that, I'm going to go eat something and then probably go to bed. So thanks for watching, and I'll see you in the future. Bye.